Today we're going to be working on another Amazon interview question. This is Leetcode question number 50, power of x and n, which means x raised power or x raised to n. So in this example, when x is this, 2, n is 10, the answer is going to be 1024. The algorithm goes like this, that when you have x equals to 2, n equals to 10, and which means the binary representation of that is going to be 1010. Our I is going to start from here, and logarithmically we're going to keep moving n to the right every single time. So the result is going to be start from 1, and every single time when you are going to be looking at the binary representation of n, and when you see this, so what is going to happen is, like, for every single one we're going to keep multiplying x with itself. So it's going to become 4. Let me just write 2 multiplied by 2, which is equal to 4. And then if it is equal to 0, nothing is gonna happen to result. But if the binary value at that digit is 1, we're gonna multiply x with the result. So we're gonna move our I here. Again, it's gonna be the we're gonna say that whatever the value of the 4 is, if it is equal to 1, this is gonna be multiplied by result, so our result is gonna become 4. And then whether or not, whatever, regardless of the value of this binary value of at this particular, the least significant, so whatever is the value of the digit where I is, x is always gonna be multiplied by itself. So this is gonna become 4 multiplied by 4, which is equal to 16. Okay, moving on. Now this time is 0. This is not gonna get multiplied by result, but it's just gonna get multiplied by itself. So 16 multiplied by 16 is equal to 256. Okay, and then the last one is here. This time this is gonna get the result is gonna get updated, and it is gonna become 256 multiplied by 4, and this is gonna be 1024, and this is gonna get updated to 256 multiplied by 256. And now this is gonna be done. Okay, the way we were moving it here, way of doing it is like you just take that n and then multiply it with 1. This is gonna give you the least significant value, and at the end you just move n to the right and move to the right by 1. And if you do it like this, you can assign the value at the same time. Move to the right and assign the value to it. Again, we'll start with the result equals to 1. Okay, one more trick here. So what if n is equal to negative? If n is negative, what you're gonna do is, like, you're gonna make x equals to 1 by x. So in this case it's gonna be 1 by 2, and make this positive. So meaning 2 raised power minus 2 is also equal to 1 by 2 square. So that's what the algorithm says, that when the n is negative, mathematically they are equal, that make the n positive but make x equals to 1 by x. That's gonna have the same value. That's basically, when this is negative, you can just do 1 by x over here. Okay, while our n is not equal to 0, as I said, we're gonna take the least significant position of n in the binary representation, and then see if that is equal to 0 or not. If it is not 0, the result is going to get multiplied by x. Otherwise, you just regardless of the value over there, this x is always gonna get multiplied by itself, and every single time we're gonna keep moving n to the right by one position, and in the end we're gonna be returning the result. We're not using any extra space, but in terms of the time complexity, we are only dependent on the value of n, and that would be the time complexity is going to be the log of n. The time complexity is not dependent on the value of the x. Whatever is the value of the x, the total number of calculations you're going to be doing depends on only on n, as we are only looking at n here, and every single time we are moving logarithmically moving, actually log of n to the base 2. So basically you are moving n, you are removing one digit in the binary representation of n. You are removing one digit, so that is basically the log of n is gonna be the time complexity here. That's all I wanted to cover in this video. Thanks for watching.